A very good morning, one and all. On behalf of the trustees, management, principal, HOD, staff, and the students of SA Engineering College, I extend a warm welcome to one and all present in this virtual platform. To know more about our college, SA Engineering College was established in the year 1998 and is successfully continuing its educational service beyond 25 years of excellence. SA Engineering College has taken the forefront of technical education through its distinctively different and carefully nurtured standards. The college is approved by the AICTE New Delhi and affiliated to Anna University, accredited by the NAC, and also has an A grade from the NAC, and also an ISO 9001 2015 certified institution. The college believes in preparation for the life ahead in all earnest and provides every opportunity to grow beyond academics. In view of the same, many in house programs like value added courses, workshops, conferences, symposiums, and guest lecture are also organized to make the students industry ready. We all have assembled here today to motivate and cherish the young minds present among us. At this juncture, I feel honored and to welcome our resource person, Dr. S. Arun Mehta, Associate Professor, Department of ECE, KLEF University, with the Tech Series 4.12 to deliver an expert talk on future trends on energy harvesting technologies for IoT. We welcome you, sir.
Good morning, ma'am.
Good morning, sir.
Yeah, thank you, ma'am. Can we start the sessions?
Yes, sir.
Yeah. I hope the screen is visible. Hello. I hope that my screen is completely visible. Thank you all, ma'am. Okay. Very good morning to one and all. First of all, I would like to thank to the management of SA Engineering College, and thanks to the Geeta ma'am to inviting me as a like resource person in this series. First of all, I would like to add one new things like I'm also that alumni of SA Engineering College. I did my BTech in that in our institute. It is like good to have after a few years, long time. So my current thanks for the introduction, ma'am. Currently, I'm working as an associate professor in KL University. I was associated with Center for Advanced Energy Studies in our institute. We are working on energy harvesting technologies. So this is what our today's topic also. The outline of the presentation, it will go with the what is an IoT. So the current trend and current requirement to the world is an Internet of Things. So we would like to have a few point on Internet IoT and how that what is the application of IoT and what is the challenges are faced by the IoT and particularly on energy. So like energy, what are all the energy harvesting methods to be can be adapted or to be utilized in for the IoT devices. And so like coming to the Internet of Things, so we would like to know like what is an Internet of Things. So the things can be connected with device to device without any human interactions. So it is we can call it like connected over internet. So it can be like person to person or machine to machine or machine to people. So like the connectivity between the device is can be operated in all the ways. So just for fun, like that cartoon you can see, the manager is giving one device to the worker just to have checking the health, right? So but the person is very happy, like okay, you are having care about my health. But the thing is the monitoring entire things of how we are heart is working, how we are whether we are relaxed or shared mode or what we are having. So it can be monitored by the person from anywhere in the world also. So how it is to be connected device to human values? It is like sets in the form of device connections, how and data sharings, sensing the data, and the data whichever it is checked or sensed by the sensor, it has to be communicated, and the communicated data has to be analysis. So data in the form of data analytics, and it has to be checked and it has to be provided to the humans, right? It is like the entire set how how that IoT connecting devices to the humans, how the development of the IoT from like in the one decade only, it is slowly growing. Like how it is to be day by day, the number of users of the IoT devices keep on increasing. Like you can see that billions of billion devices are increasing. When once we are checked with that, what is that the human population in the world, it is to be like we are reached in the year 2009, around 2009 around itself, the more than the connected peoples. Now it is more than 6 devices per persons, 6 to 7 devices. Now almost 10 devices also per person. So many devices. Why these many devices? If you are feel so comfortable and safe in any of the environment or the location, you might be identifying few devices which can be run through internet or without internet. So like this is what the development of our IoTs and the transforming through technology. We can see that existing and smart technologies. Existing technologies like the parking are lagging in the connectivity, lagging in the surveillance, and very less data information. If the power is disconnected, we can't identify where the power is disconnected. But nowadays, not in the cases. It is making in all into the smart, like smart parking, like where the parking can be checked where whether it is available, slots are available or not. Lightnings, like it without any like interfaces, that the light will be automatically turned off or turned on in such a way that it the technologies are transforming into the next level. So particularly in which field it is to be, it cannot be fixed on the one field. It can be go with multiple applications, start from the medical, wearable, logistics, and even industry, smart buildings. So now you can see entire thing is on smart. So like though it is to be growing, but while we are growing like the things to implement in the proper way, we are facing some challenges. We are facing many challenges, like insufficient testing and updating. Regarding the data security, obviously, like if you are share the data in the internet, it is lacking of security and privacy, and software complexity, and data volumes and interactions integration with AI automations. So these kind of challenges are we are facing in that implementing of IoT things in the day-to-day life. In connection with that, we are going to take one challenges and how to resolve that overcome the challenges. So we need to provide the constant power supply with it is very difficult. So now we are going to take that one as the grand challenge. Like you can like in 1 billion devices or in 2020 around, but in 2025, in 1 or 2 years, the devices more than 1 trillion IoT devices. It all need the power sources. Most of the all the will be like wireless devices, and it is very challenging to provide the power without interruptions. Okay, so like let us assume the IoT devices in the sense it is to be in the wireless connectivity. The data is stored in the wireless, but how about the power? Can we transfer the power in wireless? No, we are not transferring. We are not in a position to transferring the power. So we need to change the battery, or we need to provide the uninterrupted power supply in the nodal. The see that the devices in the nodal point in somewhere else. Okay, so the data are we are receiving the data through wireless, but how about the power? So we need to provide the battery supply. So it need to be changed frequently. So to avoid that, if it is having that inbuilt energy harvesting things, it is well and good to have a good devices continuous uninterrupted power supply for the nodal location. It kind of let us assume you are kept it somewhere in the deep forest or sea or somewhere in the terrace or somewhere. It is like difficult to replace the battery frequently. So those locations we are in a position to provide the power. So how the power? So the power is generated in the commercial, like which we are receiving our day-to-day life using only two techniques. Okay, so like how the things. Okay, the one is like rotating electric generators, another one is photovoltaic systems. Only these two. But what about different? But you may be having some questions, sir. But we are having enormous method to harvest the energy. Yes, obviously we are having. I'll show you in the next slide. Like how there is the simple concept is electric generators. Okay, so like mechanical movement is when cuts the magnetic flux, that EMF is generated. Okay, so we are connecting to the grid. See that electric generators with the types of power generation. You may have the n varieties of sources for generating energies. Okay, so the coal, oil, gas. Yes, what is the use of this? All those things to be like heating the water. The steam can be utilized as a rotate the turbine. The turbine is attached with the magnet, attached with the magnet. The generator is generating the power, so it is to be transforming from that place to another place. The next thing is, while you are coming for that renewable energy sources like hydro waves or solar or wind, all those things are the similar way. Obviously, like it is to be generate the power from like tidal. It is turbine rotations. The solar only the thing is to light energy and heat energy. The heat energy again it is to be utilized to rotate the turbine, and then wind that does also rotate the turbine. So almost that all the techniques are comes under these techniques only the and generators. Okay, but apart from that, like for commercial supplies. But when coming to that wireless technologies devices or wireless devices which we are utilizing, it is not required with that much power supply. It's in the 100 watts or 10 watts and more than that. It's not like that. We need just microvolt or nanovolt supplies only. So for these things, we no need to depend on the raw power, which is commercial power supply from the generator or with the like grid. You can have it with the small techniques like RF or vibrational or thermal or photovoltaics. Within this, we can have that energy. Okay, now we are going to see how these techniques can be utilized for harvesting the energy for this kind of our wireless technology devices. We'll see one by one. So like good amount of energy sources available in the environment. So like in and around you, like small wind is there. You can convert that small wind speed to rotate small fans. That from that we can generate the power for your small wireless devices. When go for while you are walking, the vibrations are there, like movement that can be converted. That radio frequencies, ambient radio waves are an amount of there, and solar light radiations or even in the room light, the artificial lightning, from that also we can harvest the energy. The only thing is what is required, the generation location and then power conditional unit, so that only has to be developed. So we will see one by one what is an photovoltaic effect. Just two devices, P and N. So the two semiconductor devices are coupled to form a PN junctions. Why we need to form an PN junction? So we need to make a movement of the electrons. So when the lights are falling onto the things, it free movement of electrons are ejected. The free movement of electron which is generated, that has to be go in one direction. So we are in a position to make the PN junction. So like the photovoltaic thing is converted into that electricity. So the structure is like this is what the basic structure of photovoltaic cell, like bottom, then P type and N type and grid. So the top grid is like having, why it is in the form of finger. The top grid has to collect the generated power, and moreover it is allowed to like enter the light. So it is kind of conversion of light into electricity. So I want to show you one small like the video on the photovoltaic structures, how it is works. You can see this is what one small solar cell. Apart from the in the panel, multiple cells are connected. We are forming the panels. This is the cross-sectional one. Left side is one contact, front contacts, then N-type silicon, that particular diffusion layer which the forming of that P-type silicon, and then clear contact. So once it is this is transist with common solar cell. Okay. So the cell is to be structured. So multiple cells are arranged and we are forming into the solar panels. How it is generated electricity. When the lights are falling into the solar cell, photons, which having that energy, that energy is diffused with the electrons. The movement of free electrons are coming out. The free electrons are moved into the closed circuit. It utilized for turning the light, and again it is coming back to the circuit. So this is what the solar cell is working, the generating the power. So we can utilize this for the things. But you may have the doubt whether all the times we are getting the sunlight. Yes, obviously we are not. So we have to store the energy. If not, so we can utilize the power with other coupled with another techniques. So this is what the solar cell efficiencies which is achieved by the different persons now, which we are currently using the solar cells are in and around 25% efficiency. That means like 100 instead of 100 we are getting around 25%. We are not we can't get more than 23 because the theoretical itself around 26 to 27. But how about these things, these are all concentrated? That means like you may having the magnifying glass like sun. So that kind of the more intensity also can be utilized. That is having good percentage, which can be utilized in the what you call the space, or that satellites are utilized by the multi-junction and other solar cells. Okay, that normal you might be seeing in your calculators. You might be seeing the few locations. The like very familiar one is the solar cell with the calculators, and even different types of wearables, and even your smartwatches or other things. The multiple location can be utilized by the solar panels. And next thing is, I told you right, in solar we are having two energies. One is what you call the light, another one is heat. That heat can also be utilized with the other techniques, but this one is like Seebeck effect. That means you can take two junctions. One is hot junctions and cold junctions. If use that our NPN are like what you call the N and P, two semiconductors. If you are keeping in the two different locations, if the temperature difference between like cold and hot, this will make the movement of electron. That also can be utilized as power. That is invented by the Seebeck around 1821. So now we are even let us assume your watches, smart watches. I'll show you in the next slide. So devices with what you call with the thermoelectric devices. Let us assume your body temperature is different than air atmosphere temperature is different. The small, even 1 to 2 degree temperature difference is sufficient to provide the energy for your smartwatches. So now if it is adapted with your smartwatches, you no need to worry about okay, we have forgot to charge our smartwatches. So this can be used, but only thing is the hybrid things that I want to tell you, like hybrid things. So bottom of the device you can add that 10 devices, and on top of the glass you may have the transparent solar cells. Then the two coupling is sufficient to have to without any recharging of your smartwatches, or no need to worry about charging by daily. So this is what our lab set up to test the thermoelectric generators. We are generating like one the brick is like for hot, another brick is while circulating the cold water. We are making the two different temperatures, and we are keeping our device to check whether the power supplies are getting it or not. So like just for the glimpse I want to show you this. Okay, see that. So top surface is its own. Okay, so like the temperature difference is the that's the movement of electron carrier. So obviously, you can use this also as a power supply. Okay, so I hope you are understand this particular concept of thing. Next thing which we want to go is like piezoelectric energy harvesting. Next thing is we want to see like piezoelectric energy harvesting. You might be seeing your mobile is vibrating. Yes, how the your mobile is vibrating? Like you are introducing small amount of supply to your that piezoelectric crystals that will oscillate x and y direction, so that your mobile is vibrating. So that is like one piezoelectric. The thing is reverse form. So if you are then you are supplying the supply and it is to be get vibrated, then if you are giving vibration to the device, you will get electron as energy. That is what the piezoelectric energy harvesting. Okay, so like how we can make use of our nanotechnologies or nano materials. We can form the zinc nanowires kind of things. Also we can like just elongate and release, stretch and release, stretch and release. That the moment is to be induced that movement, free movement of electrons. That while it comes out, then we can utilize for our things. You might be seeing the small what you called the like artificial tree which is available in your table. It with these like small leaves are solar cells, and the top turbine that with the fan speed like your room fan, like wind is sufficient to rotate this small fan. So and these two is sufficient to show your room temperature, and this data and monitoring your room. This data can be sense, and it has to be transferred through remote location also. This is also kind of one kind of like simple techniques to monitor your room, or like safeguard your secure your room also. And let us assume if you are going for walking daily, if these kind of piezoelectric device are kept in your shoes at the bottom, while you are walking, it is by default your mobile can get recharged. Then no need to worry to charge your mobile separately. While you are if you are going for a walking, or then your mobile will get charged. Okay, the similar way, the triboelectric nano generators. It is kind of four stage. One is like linear vertical contact separation mode. Here also like PN junctions, and if it is touched and released, then whenever it is touched, then moment of electron will appear. Okay, so that can be utilized for the device. So like it is in the not only in the touch and release, on linear motions or freestanding motions, or one is fixed, one is normal. That means how with the single mode electrode, or like let us assume your car is moving on the surface, that is kind of a freestanding electrode. So like this kind of devices we are making in our laboratory. So like just to test whether it is to be can be utilized for the this kind of shoes or somewhere. Okay, so this is what our triboelectric nano generator testing setup, which the similar way of our the similar like electrometer to be utilized for supply checking. The device, the small device you can see now, this one is like press and release. The device which we are having is like manually we are going to make the vibrations with these things, and we are going to keep this device in between, and it start vibrating, then it's generate the energy. So we are recording those energies, and it can be utilized for further IoT device applications. You might be seeing this. You will get a better understanding of the triboelectricity. Okay, this is like a top layer.
Deep in the
Yeah.
forest, a sensor monitors the occurrence of fires. There is no electrical supply and there are no solar panels, and yet it is self-powered. The secret lies in triboelectricity that fundamentally takes advantage of static electricity charges to generate energy. Thus, any movement generates a small electric current thanks to the transfer of electrons from one material to a compatible one. This allows multiple devices to be powered. But the latest research has multiplied its potential with the arrival of triboelectric nano generators. These properties are integrated into devices such as this medical patch that monitors the heartbeat. Thus, a substrate with a layer with triboelectric properties in contact with an electrode generates electricity. This glove tracks the movements of the fingers thanks to the use of integrated triboelectric fibers, with applications in gesture recognition systems. These nano generators can also be integrated into domestic elements such as this wooden floor. By stepping on it, it detects the presence of people without the need for an electrical connection, and it allows the activation of IoT devices automatically. But triboelectricity could also power a new generation of wearables, such as smart shoes or socks, to monitor physical activity. Any material has the potential to become a generator of renewable and clean energy.
So what members of Vivekanandan sir and team of they are working in this area. This is what the different nano generators designs, which is in all over the world. The peoples are approaching like different structures and like a small ball or rotary designs in different ways. The people depends on the application. If you want to test in your seashore, then it is like floating layer is sufficient to harvest the energy. So that what is the use of these kind of things? Like let us nowadays so many issues are happening in the seashore. The people is not able to understand what is the border of that one. So you can drop our things in that in that border, then it will be illuminating the light without any power supply. It will generate the energy himself, and it will light will be illuminating. Then the people can be identified. Okay, this is what we are about to reach our what you call the sea border. That kind of things is fine to have these IoT kind of devices. Even you can have the security things also, apart from that alarm. If you are you can detect what kind of small camera you can install, that can be take the peak or information about the boat or any strange movement in the sea. That also can be for the security purpose or like other purpose also can be used. So this can be utilized. So next thing is RF energy harvesting. So we are well known about that our RF source, but in that RF source we are utilizing for the transmitting the data, right? But we are transmitting the data from one location to another location. Uh, we are receiving the signal and we are converting into the data, and we are getting into the information which we are transmitted from the transmitter. And in the another way, the same RF signal can be used for like power supply to the remote location nodal unit. That is called rectana, and like receiving the same impedance matching circuit has to be adapted, and we can add the rectifier voltage multiplier in that. Okay, that power, small amount of power can be received, converted in, and it can be stored in the batteries, and we can use it again for our small wireless devices. So this is also one kind of like RF energy harvesting. So this is in our institute we are having like good amount of designing of RFs for the communication purpose, as well as converting the RF energy into the power. So like small glimpse for this for better understanding. So this is a similar way of
Researchers from the
PN
Massachusetts
junctions.
Institute of Technology created a rectifying antenna, or rectenna, using a thin molybdenum disulfide semiconductor that's only 3 atoms thick. Electromagnetic waves like Wi-Fi are captured by the device's radio frequency antenna and then converted into direct current. Antenna produced 40 microwatts power when exposed to typical Wi-Fi signals of around 150 microwatts, enough for an LED or silicon chips. According to MIT, early applications for the technology include flexible smartphones and wearable electronics. The device can also reportedly be used to power medical implants or soluble sensors in place of traditional batteries, which can leak lithium and be lethal to patients. Due to its flexibility, the device can be fabricated to cover large areas. Researchers believe it's possible to develop electronic systems that can wrap around highways, bridges, or office walls.
So so multiple things to be used. And how about the thing like, sir, which the whether the solar is sufficient to harvest the energy? Yes, it is sufficient. It depends on the continuous. Let us assume you are want to continuously monitor that your nodal unit. So it can be not sufficient with the single unit. We can hybrid, attach the multiple energy harvesters in single device, like solar and thermal, or piezo and solar, or piezo and tribo, piezo or solar and tribo, or thermo and tribo. Like multiple things can be hybrided and can be make it to be integrated energy harvesters to fulfill our energy requirement. So this hybrid multi-sources can be integrated as energy harvesters, can be utilized for multiple applications, like right from the chemical energy or thermal, mechanical, like this. We are not saying like what you called this energy harvester can replace the batteries. No, like it is like additional things can harvest the energy and to be stored in the batteries, like which means this energy generated things can be recharge the batteries, and it is no need to replace the batteries or no need to again go and plug the devices to be. It can be utilized in even for the militants application, biomedical applications, and multiple things. And even your, I told like even your what you call your smartwatches can be added with the thermoelectric generators, and the top you can add that solar cells. It can be multiple energy sources to fulfill your running of your smart things. So this is what broad perspective of our energy harvester applications, like right from your regular application and your like biomedical applications and other things like pressure sensors or your face makers or robots or biomedical sensor. These are multiple applications of our small energy harvesting things. So which how it is to be? It is like photoexciton or piezoelectricity, optoelectronic. It is all it put together. It ultimate the person is a semiconductor. The semiconductor is like more flexible person. Like you can see like if this with the semiconductor, you can make the things in reverse versions, right? You may see like light into power, solar cells, power into light, LED, piezo into like vibrator, piezoelectricity, vibrator. Again, if you are vibrate, then power. So like you can make the semiconductor to work in different form. Depends on the application, depends on the property of that semiconductor. You can tune it, you can work it any number of functions, right from even small sensors to the bulk motors. Okay, you can tune or play around the semiconductor, the properties, then you can go have the good amount of things. Okay, so like nowadays we need to have this kind of energy harvester to fulfill our power supply for our IoT devices also. In due course of time, it is keep people are working on that, but it is existing in the market also. You might be having doubt like whether these kind of sources are new to us, whether these kind of things are utilized by the companies. Yes, the good amount of companies of US, India, and China, the Switzerland, multiple companies are working on this kind of products, and these technologies can be commercially some of the locations are available also. Okay, so this is what the power is to be how which is to be more utilized. Pyro, like pyro means that is thermoelectric, tribo, piezo, and solar, and photovoltaics. Multiple things are utilized. And I want to say the thing is like uh, you can see multiple things are coming, but like future is to be like still this much technologies are done, and but we are still studying how the photosynthesis are happening completely. We are now we are completely understand how the photosynthesis are happen, but we are struggling to make the things to be mimic. That means biomimic or natural mimic things is still difficult. Like how these photosynthesis, artificial photosynthesis are still not yet invented. Say without like live like gems or the things. Since it why it is happening? Because it is working in the range of not in the nano, not in the pico, in even in the femtoseconds. The reactions are happening in even in femtoseconds to converting of the things that like utilizing the carbon dioxide, and it is to be converted into the sugar. It is like this chemical energy in the femtosecond, it is people are it is working. So still we are keep understanding how it is working. Even your brains, like one day it can be done, it may be happen, but before transplant, what is required to have how it is working. Like the heart transplant is happening, we are familiar and we are well known, we are adapted how the heart is working, so that we are transplanted artificial heart also people are trying. But still, how the human brains are working, still the researchers are going on. So when we are identified those kind of things, that day can be possible of brain transplanted or artificial brains. So that is what the things are going on. And but for the future, technologist leaders, we want to say only one thing: your technology supposed to be has to be save the world, not to kill the world. So work on that way. And any questions related to, if you have any queries up to that, we may discuss, or you can post your messages. Okay, so I want to make the last of 5 more minutes how this entire, like what you call the globe is moving towards that IoT, right from the sensor, right from the things is needed. So we would like to show you one entire the glimpse of our things in 1 minute.
Power harvesting or energy harvesting makes this possible. The advantage is a simple energy supply for hard-to-access sensors, which is useful in the field of wearables and other things. Sensors in a user's clothing or on their body record a variety of data during sport, which is then transmitted to a smartwatch and uploaded into the cloud. There is also a wide range of applications in the automotive sector, where the engine's waste heat is a good source of energy, as is tire pressure. A piezoelectric generator can convert the mechanical deformation of the tire.
Yeah, even in the tire pressure monitoring, like how it is to be, it is inside the tire, but the device has to be get power with the batteries. So instead of along with the battery, if you are having with the like piezoelectrics energy harvester attached with the device, no need to recharge the battery. It is to be get power harvest, and it is to be sense the data of the pressure sensor, and it is to be transmitted the information to your car wirelessly. That
Into
is also
electricity.
possible.
As with the user playing sport, data on the tire pressure or speed can then be generated. The potential for energy harvesting in the industrial Internet of Things, the IIoT, is vast. It can be used wherever production integrates state-of-the-art information and communications technology. In the future, wireless sensors will be employed to record more and more critical parameters to increase security and reliability while reducing maintenance. Energy harvesting enables the use of these sensors independently of the energy grid and without high-maintenance batteries. For example, when a light switch is pressed, a pressure generator can generate enough energy to transmit a signal to the receiver that controls the light, meaning that the light switch can function without having to draw electricity from the grid. To make energy harvesting suitable for everyday use, all components in a system need to be 100% compatible. The task of most systems is to transmit signals. The requirements can vary widely.
That IoT will be fulfilled with this set of hardwares, then only that IoT will function completely. The better understanding, like right from the sensor, microcontroller, and then communication devices, the transmitters or receiver, like entire thing is big. The data is very small, the just to have that values. But the hardware which we are running with the right from sensors, and that taking the decision of based on the program which you are added in the microcontroller, and that information has to be transmitted to the transceiver.
Depending on how often the readings need to be transmitted, that is, how much time there is to harvest new energy and to charge a small storage battery. So, in addition to energy converters, some perfectly compatible components are needed, like extremely efficient microcontrollers for signal processing and
here it coming to, apart from that, the IoT devices, even that energy converter completely on the based on the work function of the semiconductor, and this has to be monitored by the energy management. That means again comes under like our energy management circuits, like DC to DC or AC to DC, small conversions, and or cutoff voltage, or those things are the entire energy management. Also
equally power-saving transmitters for data transmission. To store the energy, we can use supercapacitors, which are highly efficient, low maintenance, cost-effective, and hard-wearing. For example, a t-shirt can measure the outside temperature, humidity, and heart rate, and analyze these data via a smartphone app. So, when in the distant future micro-submarines are injected into our bloodstream to provide
So, I hope you are understanding the things in well manner. Like it might be like small spark on your mind how the things are IoT things are required in the day-to-day life, and how energy harvesters. Okay, this many kinds of energy harvester also can be adapted for IoT devices. I think it like small spark in your mind. You just go through your like websites and keep understanding these kind of technologies with electronics. All the best to all the participants. Thank you for giving the opportunity. Thank you all. Any queries? Yeah. So I'll share my contact details. If any queries or any information related to this, you can contact me through this mail ID or through my mobile number. I'm very much happy to be work for you peoples or support you to getting the future technologies and better things. சார் வந்து போயிட்டாரு.
Thank you so much, sir. I'm grateful to the esteemed delegates of the webinar for their presence and efforts in making this event a great success. I also extend my sincere thanks to our honored resource person and the heads of the departments of CSE, IT, EEE, ECE, AIDS, AIML, Civil, Mechanical, CSBS, and Cybersecurity. Thank you once again, sir. The feedback link is posted in the comment section. I kindly request all the participants to fill in the feedback link. Thank you.